Okay, let's talk about molecular formulas. Molecular formulas are a multiple of the empirical formula. So if I give you H2O, which is water, and I multiply that formula by 2 or 3 or 5, the resulting formula would be known as the molecular formula. Okay? So it looks something like this. Okay? Now, there is a small problem when you are asked to calculate the molecular formula given the empirical formula, and that's what I'm going to show you how to do first. So let's take a look at student exercise 16A. It says a compound with an empirical formula of CH2O. So I'm going to write empirical formula is CH2O. Okay. So some compound with this empirical formula has a molar mass of approximately 90 grams per mole. What is the molecular formula? Okay, so since the molecular formula is a multiple of the empirical formula, and I have the mass of the molecular formula, which is 90 grams per mole, I need to find the molar mass of the empirical formula, CH2O, by looking at the periodic table. Can you guys please be quiet? Thank you. Okay. So carbon has a mass of 12.01. Hydrogen is 1.01. And then oxygen is 16. And these numbers come from the periodic table, and you're supposed to take them 2 places past the decimal and round if necessary. So 12 and 16 is about 28.01 plus 2. That's going to give me 30.03 grams per mole for the molar mass of the empirical formula. Okay. Now, 30 times what whole number would give me 90? 30 times 3 would give me 90. So since 30 times 3 is going to give me 90, that means the molecular formula is the empirical formula times 3. So take the empirical formula, CH2O, and multiply it by 3. You're going to get C3H6O3, and that is your molecular formula. Okay? Let's take a look at another problem that's identical to this one. We have a gaseous compound with an empirical formula of NO2. If its molar mass is about 92 grams per mole, what is the molecular formula? Okay. So here's the information that we were given. We have to calculate the molar mass of the empirical formula NO2, which is 14.01 for nitrogen and 2 times 16 for oxygen. So it looks like this. So you've got 32 plus 14.01, which is going to be 46.01 for the molar mass of NO2. 46 times 2 would give me 92, which is the mass of the molecular formula. So since I have to multiply by 2 to get to 92, that means the molecular formula is the empirical formula by 2. So we're going to take NO2 times 2, and we're going to get N2O4 for the molecular formula. Okay? Okay, so I did 2 short versions of molecular formula calculations. Now there is a longer version where they don't give you the empirical formula. You have to calculate it. And then after that, you add the short step that we just learned. So if you take a look at C, you've got a compound with a molar mass of about 180 grams per mole and a percent composition of 40% carbon. So that really means I have 40 grams of carbon, 6.72% hydrogen, which is really 6.72 grams of hydrogen, and 53.92% oxygen, or 53.92 grams of oxygen. All right, so we have to calculate the empirical formula first, which means you need to convert grams to moles. So I'm going to divide by the molar masses. So it looks like this. And when you get your moles, you want to write out maybe 5 places past the decimal. You don't want to round. Don't use sig figs. So I've got 3.3305 moles of C. And I've got 6.6534 moles of hydrogen. And 3.37 moles of oxygen. So it looks like this. Once you get moles of each element, you want to divide by the smallest mole. The smallest mole is carbon, which is 3.3305. So divide by the smallest mole. And you're going to get these whole numbers, which are the subscripts in the empirical formula. So the empirical formula is CH2O. Okay. They asked us to calculate the molecular formula. The molecular formula has a mass of 180 grams per mole. Okay, so we need to get the molar mass of the empirical formula so we can figure out what we need to multiply it by to get the molecular formula. Well, we calculated the molar mass of the empirical formula in a previous problem. It came out to be 30.03 grams per mole. So if I take 30 and I multiply it by 6, I'm going to get 180. So since I multiply 30 by 6 to get to 180, that means you need to multiply CH2O by 6 to get C6H12O6. And that's the molecular formula. Okay, now you're ready to do the worksheet on molecular formula.